Engines are the heart of our industrial machines. We expect our engines to be absolutely reliable, have a long life cycle, and be economical even under difficult operating conditions. Modern diesel engines are an expensive investment and well worth protecting. Mann and Hummel filters are perfectly able to handle this demanding task. Well-known engine manufacturers know this and appreciate Mann and Hummel as a development partner for all engine filtration requirements. Filters ensure the reliable functioning of the engine under all operating conditions. The failure of just one filter changes engine performance and fuel consumption and can lead to a machine stoppage. Air cleaners prevent ingress of dust from the ambient air into the engine. The engine is supplied with filtered air according to the manufacturer's specifications and so is able to breathe freely. Oil filters in the main oil circuit clean the blood of the engine. They remove particles from the oil resulting from combustion and engine wear. After separation, the cleaned oil reaches the fine bearing gaps and lubricating points. The oil in diesel engines is additionally exposed to constant contamination from soot. Therefore, larger industrial engines are usually fitted with centrifuges. These are able to considerably reduce the amount of soot contamination. Fuel is food for the engine. Modern diesel engines are equipped with ultra-sensitive injection systems, and it's important to protect these systems against ingress of particles and water. The pre-line preliminary fuel filter separates water from the fuel, and the main filter protects the injection system against the ingress of particles. Due to environmental considerations, more and more industrial engines are being equipped with cleaning systems for blow-by gases. The extensive experience of Mann and Hummel in this complex field makes the company a first-rate supplier. Diesel particulate filters contribute significantly to the eco-friendly operation of diesel engines. They considerably reduce emissions of breathable particles. Mann and Hummel is able to offer customized solutions for applications. Mann and Hummel filters are fine-tuned to work together and are developed in cooperation with leading engine manufacturers. The result is perfect protection for the engine and the environment with a minimum of running costs. Combustion air always contains particles. These particles must not be allowed to penetrate the inside of the engine. Single-stage cleaners are suitable for applications subject to low amounts of dust. For larger amounts of dust, such as with off-road applications, two-stage cleaners are standard. In two-stage cleaners, most of the particles are separated in the first filtration stage by the pre-separator and discharged from the filter via the dust discharge valve, which considerably lengthens the service life of the filter element. The pre-cleaned air flows through the filter element and the optional secondary element to the engine. The secondary element prevents ingress of dirt into the engine when changing the filter element in the field. Mann and Hummel filters use filter media characterized by a high separation efficiency and high dust holding capacity. The high separation efficiency ensures that very small particles are also reliably separated in the depth of the filter medium. A high dust holding capacity means a long service life for the filter. Mann and Hummel filter media have a special impregnation which provides good protection against the ingress of moisture. The impregnation prevents water from penetrating the depth of the medium where swelling can render the medium unusable. The pleated bellows of Mann and Hummel air cleaners are stabilized to ensure that they maintain their shape under all operating conditions, allowing an ideal airflow. But even the best filter element eventually reaches the end of its service life and must then be replaced. In the ideal case, the cleaner is equipped with an optional service indicator or service switch. These devices signal the correct time to service the air cleaner based on the load status of the filter element. Servicing is limited to replacement of the main filter element. After approximately 3 changes of the main filter element, the secondary element should also be replaced. Cheap air cleaners are often already damaged when they leave the production. The low-quality medium used in cheap cleaners often tears, and this can allow unfiltered air to penetrate the engine. In the production process, the material is compressed. This leads to a reduction of the effective filtration surface area, with a correspondingly lower dirt holding capacity. It is difficult to recognize inadequate impregnation in cheap filters when they're new. However, in operation, the elements take on moisture, and as a result, the unprotected filter paper swells up and becomes wavy. Cheap filters often do not sufficiently stabilize the paper pleats, with the result that these stick together and then filtration surface area is lost. The airflow rate increases, the separation efficiency goes down, and the medium can tear. The bellows of cheap filters are frequently not closed. The pleats merely overlap, and this means a continuous bypass is inevitable. Cheap filters also cut corners with the type of sealing material used. When the low-quality material is exposed to engine vibration and temperature changes, it loses its required elasticity. Cracks form, and unfiltered air can penetrate the engine. With air cleaners from Mann and Hummel, you're on the safe side. Oil performs 2 important functions in engines. Firstly, it lubricates all the moving parts, and secondly, during engine operation, it conducts heat from combustion and friction to the engine cooling circuit. For the oil to perform these functions, it has to be continuously cleaned through separation of abrasive particles contained in combustion gases, which flow past the piston, called blow-by gases. Oil filtration includes the main flow and the bypass flow. Each engine is equipped with a main filter, and larger industrial engines are also fitted with a centrifuge as a bypass filter. The main filter filters the oil, which goes directly to the lubrication points in the engine. The centrifuge in the bypass flow only receives a part of the oil flow and separates particularly fine particles from soot and abrasive metal. In industry, spin-on filters are frequently used for the main filter due to their robustness and easy servicing. Oil flows into the filter head, and with a twin-head system flows equally to both spin-on filters. When one filter is changed, the oil flow is switched to the other filter. The task of filtration is handled by the deep bed medium. Initially, with an engine cold start, the oil is viscous. In order to avoid an inadmissible high rise in pressure, each oil circuit has a bypass valve somewhere in the circuit. It opens at a predefined differential pressure level and closes again when the oil becomes less viscous as the temperature increases. In the course of operation, the filter accepts dirt particles, and this causes the differential pressure over the filter to increase. The filter must always be changed according to the specifications of the engine manufacturer. If there is no specification, we recommend fitting a service switch or service indicator into the filter head. If the filter is fitted in a vertical position, it can be fitted with an anti-drain valve to prevent the filter emptying when the engine stops. Bad quality filters are packaged attractively and are difficult to recognize as inferior. Cheap filters do not take the balance between dirt holding capacity and filter fineness into account. Insufficient dirt holding capacity results in a shortened service life or inadequate filter fineness. The filter medium is simply not able to handle the stress of the oil circuit. It becomes brittle prematurely, can tear, and the engine is exposed to unfiltered oil. Elastomers become brittle and lose their sealing characteristics, leading to a visible loss of oil and internal invisible bypasses at the bypass valve. At the bypass valve, a low-quality spring leads to a continual opening of the valve. If the bypass valve opens too late, this will sooner or later lead to damage in the oil circuit and leaks will occur. It is not uncommon for the bypass valve to have no guiding right from the start and to block already when new. If cost-cutting also results in a substandard center tube, differential pressure will build to an inadmissible level and lead to a collapse of the filter element and total failure of the filter. Cheap filters save money with the housing, and this compromises reliability. The consequences of a burst filter are fatal for the engine. Internal values not necessarily visible from the outside are of particular importance for oil filters. Mann and Hummel produces filters in OEM quality as standard, and this gives you the security of knowing that your engine is reliably protected. Small particles in oil arising from metal abrasion or soot can also cause wear. Piston liners are covered by a thin film of oil to enable smooth running of the pistons. The oil is maintained on the fine surface structure of the liners. Ultrafine particles in the lubricating oil act like sandpaper and destroy the surface through smoothing, and as a result, the running characteristics of the pistons deteriorate. Another effect is that more exhaust gas can enter the crankcase and the amount of blow-by gas in the engine increases. Fine particles also lead to wear in the main bearings when the engine starts and stops if the lubricating film has not sufficiently formed. A further effect is that ultrafine particles lead to increased oil viscosity. Oil thickens and is harder to pump. The result is inadequate engine lubrication and higher fuel consumption. Finally, the effectiveness of the oil thickens and is harder to pump. The result is inadequate engine lubrication and higher fuel consumption. Finally, the effectiveness of the oil additive is also compromised by soot particles. The centrifuge helps make the additive effective for a longer period. These fine contaminants in the lube oil are filtered out by the centrifuge fitted to the bypass. On the pump pressure side, part of the oil flow is directed to the centrifuge. The pump pressure forces the oil via a hollow spindle in the rotor. The rotor then fills with oil. In a way similar to the principle of jet propulsion, the rotor is then forced to rotate. Particles are displaced through centrifugal force and deposit on the rotor wall to form a filter cake. After separation, the oil leaves the rotor through tangential nozzles. The centrifuge is opened and cleaned according to the specifications of the engine manufacturer. The oil is directed to the oil sump. The centrifuge has a direct influence on the economical operation of the engine. It significantly reduces engine wear, leads to a longer engine life, and reduces the costs for lubrication oil. The long journey of diesel fuel from the refinery to the filling station and vehicle tank up to use in the fuel injection system exposes the fuel to a number of contamination sources. Contaminants can be particles, but may also be just water. Modern injection systems generate pressure substantially over 1000 bar. This enables adequate fuel atomization to ensure efficient combustion. These injection systems are sensitive to fuel contaminants from particles or water. Free water sometimes appears if there are temperature fluctuations. This leads to corrosion in various parts of the injection system, with considerably more wear and consequential damage through rust particles carried with the water. Mann and Hummel fuel filters for water separation with filter media such as the patented multigrade media offer effective protection for the injection system against ingress of water. As an option, the preliminary filter is also available with electrical heating for improved flow characteristics at low temperatures. A water sensor is also available for automatic water detection. The preliminary filter is usually fitted to the suction side of the engine fuel pump. The free water drops there are relatively big and therefore better to separate than after going through the feed pump, where they are agitated and become smaller. The preliminary filter is naturally also able to separate coarse particles. This means that all system components downstream are protected and the service life of the main filter is extended. So how does water separation work? Mann and Hummel uses hydrophobic filter media to separate water. Small water droplets collect on the media surface and these grow to become larger drops. Gravity acts on these large drops. Water is heavier than diesel, and so the large drops sink down to the water collector in the preliminary filter. Servicing is easy. At regular intervals, the water screw is opened and the separated water is removed from the water collector. The spin-on filter is replaced according to the specifications of the engine manufacturer. The system is ventilated by opening the air vent screw and operating the manual pump. The filter is ready for operation almost immediately. In particular, sensitive components such as the high pressure pump and the injection nozzles have a very fine clearance. At high pressures, the fuel has to be cleaner because any particles in the fuel fly around in an abrasive and destructive manner. The result is internal leaks, injection volume loss, and even total failure of the injection system. The main filter ensures that these small destructive particles are not given the chance to damage the injection system. The main filter is usually fitted to the pressure side of the engine fuel pump. The available pressure drop is higher there than on the suction side, and this has a positive effect on the service life of the main fuel filter as particle separator. Mann and Hummel has an extensive range of different media for the various types of injection systems. As is usual with spin-on filters, servicing is limited to the replacement of the filter according to the specifications of the engine manufacturer. It is often difficult to see the risk of using cheap filters. They look okay on the outside, but the inside of the housing is already rusting and therefore weak. Damage caused by cracked and leaking filters is just a question of time. Frequently, cheap filters do not have the required separation efficiency, and so particles are able to pass through to the clean side and damage the injection system. Their service life is also very limited. Their low particle holding capacity quickly leads to higher differential pressure, and the engine receives insufficient fuel, which leads to a loss of performance. In the worst case, the medium will tear, and the highly sensitive injection system receives completely unfiltered fuel. Crankcase ventilation is an inconspicuous but technically innovative separation method to lower engine emissions. We have to look at the inside of the engine to understand how crankcase ventilation works. During the combustion cycle, leakage between the piston rings and liners causes combustion gases to enter the crankcase. These gases, which come from the combustion process, have a composition similar to exhaust gas. They are called blow-by gases. In the crankcase, the blow-by gas is enriched with oil. This gas is not eco-friendly, but still has to be continually removed from the crankcase to prevent an inadmissible rise in pressure. In the simplest case, this removal is made via an opening in the crankcase. However, this method results in a continual loss of engine oil and is no longer environmentally acceptable as a solution. A better solution is to remove the blow-by gas via an extraction point on the engine, such as via the rocker cover, and ventilate the crankcase using a highly efficient oil separator. The separator can be operated as an open system where the cleaned blow-by gases are returned to the ambient air. A state-of-the-art feature is the closed crankcase ventilation system, where blow-by gases are recirculated to the engine air intake to return to the combustion process. The oil separator exploits the principle of coalescence to separate the oil. As blow-by gases pass through the medium, small oil droplets collect on the fibers of the separation medium, grow and then exit the filter in drops on the outlet side, where they return to the oil sump. The cleaned blow-by gases are then returned to the engine air intake and sucked in again by the engine. With closed crankcase ventilation, there is a hydraulic connection between the engine air intake and the crankcase. Therefore, the constantly changing pressure difference between the air intake and crankcase must be compensated for by pressure regulation to ensure the pressure level is suitable for the crankcase. Due to the adjustment of the pressure in the oil sump, the oil recirculation usually takes place below the oil sump. The oil column in the drainage pipe then prevents a bypass via the drainage pipe to the air intake. If this is not possible or not desired, the oil recirculation can optionally be made above the oil level. In this case, Mann and Hummel offers a valve for fitting in the drainage pipe, which will prevent this bypass. As a further option, Mann and Hummel offers a pressure relief valve for a number of crankcase ventilation systems, which prevents inadmissibly high crankcase pressure in the event that the engine fails. The servicing of the oil separator could not be easier. The crankcase is opened without tools. Then the separation element is replaced according to the specifications of the engine manufacturer. Modern diesel engines are frequently supercharged to realise high performance with ever smaller engines. The result is that soot particles in the exhaust gas are becoming ever smaller and barely detectable to the human eye. The separation of very small particles is a challenge for the filter medium. Improved back pressure exhaust gas characteristics, long service life, and high filter efficiency for ultra-small particles are good arguments in favour of the sintered metal filters from Mann and Hummel. The filtered soot particles deposit themselves on the filter surface, and the soot particles form a filter cake. The active electronics monitor this process and automatically trigger regeneration. The vehicle driver is not aware of the regeneration process. An electric heater ignites the filter cake without direct contact, and the regeneration is carried out automatically. The cleaned filter is now as good as new, apart from a small amount of ashes which, due to the open design of the sintered metal filter, falls to the bottom of the filter. Depending on the application, the ashes must be removed from the filter after a time period of up to 2,500 hours. High filter efficiency, long service life, easy servicing, and unlimited availability of the application. All these arguments make Mann and Hummel diesel particulate filters the ideal solution for your engine and the environment.